Well, hi, geometry. Welcome to, let's move this, 5.1, mid-segment theorem and coordinate proof. So I wonder if that should say plain, but in any case. Yeah, you see all the answers here because I've already done this whole video, and I've been going through ink like crazy, so I didn't want to print out another one, so bear with me. What I'll do is cover up the answers, and we'll go from there. So let me take the bottom sheet and cover that up, and you might have to pause this a few times, copy down what I've written, because this will probably go faster if I don't have to write it down also. Okay, so my learning targets, we're going to use mid-segments for the coordinate plane. That's your x and y axes, and mid-segment is exactly what it sounds like. It's the midpoint of sides, and you connect. I can use triangle mid-segment theorem to find distances. So here we go. Warm up. Well, the first thing I did was, let's see, how can I, here, we'll take the remote, cover up answers. Okay, so first thing I did was I copied down the ordered pair. So please make sure that you take some of your graph paper out, those little graph paper sheets that are Post-it notes, they're really nice. So A is 0, 10, B is 6, 0, C is 0, 0. And then it says find AB. Okay, so recall this length. We have a right triangle here. You can use Pythagorean theorem. A squared plus B squared is equal to C squared. So 10 squared plus 6 squared equals C squared, but take the square root, you'll have your answer. And I thought I'd help you out a little bit. It's approximately 11.66. Now, find the midpoint of CA. Well, here's CA. The whole length is 10, so halfway through would be 5. So the midpoint is 0, 5. Find the midpoint of AB. And if you recall, I know this whole length is 6. Halfway through would be, I'm sorry, I'm finding it for AB. Remember what you have to do. You have to take the two x points, 0 plus 6, divide by 2. Take the two y points, 10 plus 0, divide by 2. So you get the ordered pair 3, 5. Go over 3 up 5. There it is. This right here, this segment, is called a mid-segment. Okay, but we're not there yet. We're actually going to define it and find the theorem of it on page 2. So we're going to play around with it first. And then find the slope of AB. Okay, the slope of AB, to go from A to B, I had to go down 10 over 6. That reduces to negative 5/3. So I know you're probably wondering, why are we finding distances, midpoints, and slopes? You're going to use that a lot for this. So I would take advantage of those programs you have. All right, here we go. A little activity. First, we're going to draw the vertices of triangle ABC. Okay, so I went ahead and drew, it's not ABC, it's ABO. Find the midpoints of OA and OB. So if this length is 8, the midpoint is 4. If this length is 6, the midpoint is 3. And label them D and E. Okay? So then it says find the slope of AB and DE. So the slope of AB, to go from A to B, I have to go down 8 over 6, which reduces to negative 4/3. Find the slope of DE. I have to go down 4 over 3, which is negative 4/3. Pretty interesting, huh? What do you notice? They're the same. Now let's find the distance of AB and DE. So the distance, I'm going to use Pythagorean theorem. 8 squared plus 6 squared is equal to AB squared. Or just take the square root. 8 squared plus 6 squared. 64 plus 36, it's 100. The square root of 100 is 10. So this whole length is 10. And then for DE, A squared plus B squared is equal to that length squared. So remember, half of 8 is 4. 4 squared plus 3 squared. 4 squared is 16. Plus 9 is 25, so it's 5. And what do you notice? Half. Okay. Repeat the steps 1 through 4, but we'll use these 3 ordered pairs. Go ahead and do that. So find the midpoints. Find the midpoints. Okay, if this whole length is 10, D is 5. If this whole length is 5, E is 2.5. And draw. Find the slope of each one. To go from A to B, I have to go down 10 over 5, which is negative 2. To find the slope of DE, you have to go down 5 over 2.5, which is negative 2. So the slopes are the same, just like they were for this one. Now let's find the distances. The distance for AB, we have a squared plus b squared equals c squared. So 10 squared plus 5 squared. Help you out here, take the square root, it's approximately 11.18. And then the distance for DE, 5 squared plus 2.5 squared, take the square root. It's about half. So what do you notice? Slopes are parallel. Mid-segment is half the length of the whole segment. So far so good? Okay. I know you probably had to pause this. Sorry about that. It'll also make that video shorter. Ooh, so here we go. All these things I already drew in. A mid-segment, here's our definition. Mid-segment of a triangle is a segment that connects the midpoints of two sides of a triangle. Every triangle has 3 of them. So the midpoint of AB is D, so that means this length is the same as this one. The midpoint of BC is F, so this length is the same as this. And then the midpoint of AC is E. So I have 3 little lines here, 3 little lines here. Also, what we just discovered, they're parallel. See how this has one little arrow parallel to this one. 2 arrows, 2 arrows. 3 arrows, 3 arrows. So all parallel, all half the length. So parallel lines have the same slope. Okay, here's our mid-segment theorem, which we're going to prove at the end. We're not going to do I guess it is, I put it in a formal proof, it's just a little different. It's more like a coordinate proof, you'll see. Alright, so here we go. A segment connecting the midpoints to 2 sides of a triangle is parallel to the third side and is half as long as that side. So, see these arrows? They're parallel. This is a mid-segment because these 2 are congruent. These 2 are congruent. This is going to be half the length. So DE is equal to half of AB. So I circled it and then I decorated it. This is very important. You'll be surprised at how often this will pop up. Now let's play around. Lots of math here. Hang in there. Alright, so draw JKL. JKL. You might want to take time out and pause. Find the mid-segment MN. Okay, so I found the midpoint of JK. Take your 2 x's, add them up, divide by 2. Take the 2 y's, add them up, divide by 2. So we get negative 4, 3. Go over negative 4 up 3, there's M. Now let's find the midpoint of KL. Take the 2 x's, add them up, divide by 2. Look at that. You're going to get a 0 here. Take the 2 y's, add them up, divide by 2. So go over 0 up 2. There's N. Okay? So that's how you're going to find mid-segments. Now let's prove it. So we got to find the slopes. Okay. So the slope for JL, you have to go down to 1, 2 over 8, which is negative 1/4. And then the slope for MN, you have to go down 1 over 4. Now I know sometimes it seems like this is always going to be half of that. It just depends how long that segment is, so you've got to be careful. Don't assume it's always half. But it's a good idea. The distance of MN. Okay, because remember, once you find the midpoint, or the mid-segment, the slopes are the same, the distance will be half. So, helping you out, remember you have to find the change of x's. So we want it for MN. So take your 2 x values, these 2 right here, take the difference, square it, plus take the difference of your 2 y values, square it. Work with me. It's about 4.123. Now the distance of JL. So take your 2x values, find the difference. I think I have an issue here. Oh, JL. Negative 6 minus 2. Quantity squared. Plus the difference of the y's. 1 minus a negative 1. I'm good. And that's going to be about twice the length as that. All right. Next page. Page 3. Now let's apply this puppy. So you have an A-frame house. Hopefully that picture is drawn. Otherwise, you'll have to take some time off. Can you see the A, B? Right there's G. Here's H and F. I'm not sure. I would guess C would be right there, but we don't need it. Okay. Shown in the diagram of an A-frame house, DG and DH are midsegments of ABF. Okay. That's this half triangle. Now, AF is 12. This whole length is 12. So that means this midsegment, DG, is going to be 6. DH is a midsegment, is 10. So that means BF is the full segment, will be 20. And that's how you'll apply this. Why would you ever need to know that? Well, if you live in an A-frame headboard and you have a really high headboard on your bed or something, you got to figure out, can you put it along that wall? Probably not. You'll probably put it along this wall. All right. Example 3. So here we go. Here's a little bit of a kind of a paragraph proof, I guess. In this diagram, RS is congruent to TS. So that's this segment and this segment. RW is congruent to VW, this segment and this segment. Okay, so if that's a midpoint and this is a midpoint, this is going to be a midsegment of this whole triangle. So prove that they're parallel. Well, here we go. First of all, these two are given. We know that. And then that means S and W are midpoints of RT and RV. Okay, so I pointed that out earlier. So if these two are midpoints, when you connect them, it's a midsegment of that triangle. So that this whole triangle right here, this is our midsegment. And if it's a midsegment, then we know this is parallel to that because of our midsegment theorem. Okay, example 4. Place a square on a right triangle in a coordinate plane in a way that is convenient for finding the side lengths. Assign coordinates to each. And then they want us to find the length and the midpoint of this diagonal. And then they wanted to find the order pair of this midsegment. Okay, so here we go. I drew a triangle or a square, and I didn't know how high or how tall this is, so I just said h. 0h. That's how high it is. Well, since it's a square, that means this length is also h0. And to get to this point, we have to go over h up h. So the order pair for the square is hh. Now, to find the length of this diagonal. Okay, so remember you have to take the difference of the x's, so h minus 0, square it, and the difference of the y's, 0 minus h, square it. So you have h squared plus h squared, which is 2h squared, and that will be the square root of that. So that would be the length. This just comes in handy. If you have a square, you can kind of figure out the length of that. Okay, midpoint. Midpoint, remember, you take your two x's, add them up, divide by 2. Take your two y's, add them up, divide by 2. So you get h over 2, h over 2. Right triangle. Again, I have this big right triangle here, and they want us to find the order pair of a midsegment. So this is scaling. I didn't know how high this would be, so I just said h. So 0h. And since it's scaling, this cannot be h0. It has to be a different value, so I made it k0. I like that better. So the midpoint, halfway up to h, would be h over 2. Halfway across to k would be k over 2. So here are the two endpoints of that midsegment. And last but not least is our lovely little proof. Woo, upside down. Okay, now there's a big side note here. We have to do all this work first in order to show the proof. So technically, it's a coordinate proof because we're showing numerical values and stuff like that. Take a look at how the order pairs were designed for this triangle. 0, 0, go over 2a up 0, and then to get this point, we had to go over 2b up 2c. Okay. So let's. We want to find the theorem for the midsegment parallel to OB. So that should be an R, I believe. Wait. In any case, I think I have the wrong one here. Okay, so let's find the midpoint of PQ. That's kind of hard to see. Why is that hard to see? I'm having lighting issues. Different times of the day. Oh, there we go. All right, but then now you can't see the diagram really well. Okay, so to find the midpoint of PQ. So PQ is from here to here. Remember, you take the two x's, 2b plus 0, and then divide by 2. You get b. Then take the two y's, 2c plus 0, then divide by 2. You get c. So the midpoint of PQ is BC. And then the midpoint of PR, same thing. Take your two x's, 2b plus 2a, okay? Then divide by 2. You're going to get b plus a. And then take your two y's, 2c plus 0, divide by 2. You get just c. So here are the midpoints. Now, the slopes are the same. Yeah, you can look right away that they're parallel, but go ahead and find the slope of mn. Okay, so remember the order pair here is BC, and the order pair here is whatchamacallit, is right here. PR is b plus a and then c. So to find the slope, you change of y's, remember the y's are on top, over the change of x's. So b plus a minus b. The b's will cancel, you get 0 over a, which is 0. Now the slope of QR, just go ahead and take the y's, 0 minus 0 over 0 minus 2a, you get 0 over 2a, you still get 0. So the slopes are 0 because they're horizontal lines. The distances, the QR, the change of x's, so I put 0 minus 2a quantity squared plus the change of y's, 0 minus 0, you're going to get 2a. And then we have to find the change of your x's, b minus b plus a quantity squared, and then c minus c quantity squared. Well, if you distribute the b, here the b's will, distribute the negative, the b's are gone, you'll have a squared. When you square and square root cancel, you just get a. Look at this. That's half. They're parallel. All right, so the proof itself, it's pretty straightforward. Okay, mn is the midsegment, that's given. And then c to the right. The slopes are the same. Definition of slope. The full length is 2a, the midsegment length is a, so distance formula gave it to me. And then mn is, because of these, mn is parallel and to QR, and mn is half of QR, so that's our midsegment theorem. So basically, we wanted these two things to show that we have midsegment theorem. Here's our homework assignment. Yeah, not very creative here, but I like multiples of 3. And there's your Common Core standard. And let's cross our fingers that this recorded this time. When I look at the screen, it shows it is. Have a nice evening.